Hello, here we go. Unit 1, Video 5, Sketching Polynomial Graphs. All right, so we've been doing a lot of work with polynomials, whether you know it or not, because even a quadratic is a polynomial. So something, like x, whoa, I'm in blue. I didn't even notice. X squared, let's say, minus 3x minus 4 is a polynomial, but we give it a special name, quadratic. If I wanted to graph this thing quickly, have a rough sketch, well, vertex form is one way we do this. The other way we do this is by finding its X-Intercept form. Now, here we go. If I'm going to graph this, normally I would call it y equals that, or I might call it f of x equals that, or what the heck, I could call it g of x, different things. We will get into more function notation later, but here's what I'm basically going to be doing. I'm going to be breaking this thing down by factoring, and I'm going to factor it and say, well, I need a positive times a negative to get a negative 4. When I combine the information, when I check my answer when I factor, I want to make sure that it ends up being a negative 3x. So what I've done is I've basically broken this thing up into its smaller components, or its binomial factors. So here's how this works. The original problem that they have us sketch the graph of might be in prefactored form, or it might be in factored form. If you look, here's the practice sheet that I want you to work on. Here's the 20 graphs I want you to draw for me. You'll notice some of them are already factored. Some of them you need to factor in order to sketch the graphs. So here's what I want to do. I want to focus on the ones that are already factored first, but here's my little heads up to you. They are going to be rough sketches. The only thing you're really going to be able to do for me is show me the end behavior and I'll explain end behavior. You're going to tell me the end behavior. You're going to tell me the x-intercepts, of course, because you can't graph it without it. And if possible, you're going to name the y-intercept for me. So let's just look at this little tiny example to begin with, then we're going to go a little bit bigger here. But if I want to sketch a graph, I've got an x and a y, right? So I factored this. I set this equal to 0, this quadratic. If I set this thing equal to 0, this means I have a point of intersection at -1 because of, I'm going to go to black here. I have an intersection at -1. I have an intersection at 4. This is a parabolic function. It happens to be an even-powered function. Even power. Now, even-powered functions will go either up on the right, up on the left, or down on the right, down on the left. This function does not happen to have a negative here, so it's going to go up on both sides. And it is parabolic. We know this, so I'm just going to sketch a quick graph here. And by sketching it, you should have noticed that I must have crossed the y-axis here. Well, I crossed the y-axis. Where was that? Well, the y-intercept would have been at -4 for this one. I can do that two different ways. I can assume if this were a 0 and this were a 0, -4 would have been the result. Or I could plug in 0 for x here. I could plug in 0 for x here. And I'd be left with a statement of 1 times -4. So here's what we're going to be doing. I'm going to start you off with after factored form. So let's look at a couple examples. But there's my 20 questions. You're going to sketch the graph for me. And then, of course, there's an answer key for all that stuff. But we'll get to that in a second. Let's just take a look at a couple basics. So first things first. I'm going to do two examples. I'm going to say y equals, and this one I'm going to do this guy right here. That's my first one. Then I am going to do one next to it so we can compare it. This time I'll call it g of x. What the heck? Got to call it something. And I'm going to do something like this. Now, both of these problems here, both of these problems are third-degree polynomials. Now, you might go, okay, what does that mean? Well, third degree means it's odd degree. Both of these are odd degree. If a problem is in factored form, this is a linear factor. The power is a 1, we just don't write it in. The power is a 1, we don't write it in. Power is a 1, we don't write it in. Heck, there's a coefficient of 1 right here. I didn't write that in either because it just looks weird. But to find out the degree of a polynomial, you would add those factors. So 1 plus 1 plus 1 more, this is degree 3. And if it's degree 3, it has what's called end behavior, where it will go down on the left and up on the right. Don't worry, you'll get used to it. Here we go. Let's draw a picture. It's a rough sketch. It's not going to be perfectly to scale. It won't, but it's going to be a good indicator what it's doing. So what I'm going to be doing here is setting these equal to 0 in my head, and they're not hard to do. I'd have to plug in a -4. That's one of my x-intercepts for this graph. I'd have to plug in a -1. That's another x-intercept. I would be all the way over here at +3. That would be an intercept. So here's what I mean by end behavior. The last dot on my x-axis over here, it means when I connect all these dots, it's going to go up through there. On the last dot on the left-hand side, it's going to go down through there. My job is to connect this x-intercept with this x-intercept with this x-intercept. That is a polynomial graph that you're going to sketch. So take a look down here. Look at how my graphs look. That's how your homework answers are going to look. Okay, your homework answers are going to look like that. But as you'll notice here, in order to sketch this graph, I had to cross the y-axis at some location. That location happens to be -12 for this one. So I'm just labeling it. That's how my answer key looks. That's how your work should look. How do you find a y-intercept? Well, for anything mathematical, if you want to know where it crosses the y, you plug in x equals 0. So you say when x equals 0, I would be left with not x plus 4, but 0 plus 4. I'd get 4. Not x plus 1, but 0 plus 1. I'd get a 1. Not x minus 3, but -3. What's 4 times 1 times -3? It is indeed -12. So when x is 0, I plug in 0 for all these dudes. I get out y equals -12, so that's my y-intercept. This right here is the answer for sketching this graph. Let's do it again. I'm going to try and not cloud the picture up with a bunch of stuff. So let's look at this one. Well, this guy's a first power. They didn't, if it was something else, that guy's a first power, that guy's a first power. Add them all up. What is this guy? He's degree 3. He is. And I don't see a negative in front of that stuff, so the end behavior, what's it going to do on this side? What's it going to do on this side? It's going to do the same pattern as the other one. I'm going to sketch this graph. So it's going to be a rough sketch. It's not going to be perfect, but it's going to be pretty good indicating what's happening. Hey, I know that this means it's going to cross the x-axis at 3. I know that. And I know that this part here means it's going to cross the x-axis at -2. I know that. So what does this little singleton mean? Well, whenever you have x singled out like that, and you want to know where it crosses the x-axis, well, you could write it like this. It's going to cross at the origin. That's what that means. Now, the good news is, If this graph is going to cross right here at the origin, I already know the y-intercept. The y-intercept is at 0. You cannot cross at the origin without that being true. So here we go. It's going to go up, and it's going to go down on this side, and in between, it's going to have to turn around somewhere, somewhere, come back and connect to that. Now, once again, rough sketch. How low did this really go? I don't know, and I don't care, because that's not our lesson today. How high did this peak hit? Don't know, don't care. That's not part of our lesson today. We're just after getting a rough idea of what this graph is doing. Now, this concept here, where I know the degree and I know what's going to happen on the ends of the the graph, that's called end behavior. We talked about that. So end behavior I've got to get a little bit more into. Y-intercept. Well, you plug in x equals 0, you find a y-intercept. That's not super difficult to understand. X-intercepts, well, you're setting each component equal to 0 to find out the x-intercepts. That's not that horrible. But one thing I have not touched on is what happens if it's fourth power? What if it's fifth power? Let's look at my practice problems I made up here. I can see this one, number 11. There's one of these. There's 2, 3, there's 4. That guy is degree 4. That's an even degreed function. I'm going to get rid of all that junk. But that's an even degreed function. Take a look at this one. We haven't even done it yet where it's not factored for us, but that guy is not a degree 8 function. There's a difference between factored form and non-factored form. Let's just talk about the ones that are factored for now, okay? So let's look at something that looks like this. Here, I'm going to speed past my answer key for now. I am. And we're going to just take a look at a couple problems here. I'm going to use function notation because that's our next unit coming up. So I'm going to say f of x equals, and then I'm going to give you guys one of each kind. And when I say one of each kind, you might say, what does that mean? Boom. That's what I mean by one of each kind. This guy is a first power. But this guy right here, this next one, x plus 2, that is clearly a second power. And x minus 4 cubed, that is definitely a cubic, or a third power. Now, when it is a first power, I call those singles. When it's a second power, I call those doubles. When it's a third power, I call them triples. Okay, now what if it's fourth power? Don't worry about it. We're not doing anything higher than power of 3 today. Well, what if it's fifth power? That would be higher than 3, so we're not doing that today. We're just going to look at the difference between a single, a double, and a triple. And by the way, if you know what doubles do, you would know what 4th, 6th, 8th, 10th, 12th, 14th, 16th power things do too. If it's even, it behaves the same way as a double. And if it's odd, like triple, what would that, 5, 7, 9, I drew a blank there. Quintuple. Anyway, those all behave the same. So let's talk about behavior here. This is for X-intercepts, how they behave. Singles, they will cross the x-axis. They will go straight through. A double root will bounce. I'll explain that in a second. And a triple will twist. Let's take a look. Here we go. I'm going to draw this graph. When you guys draw graphs for me, they are rough sketches. They will not match up with your graphing calculator exactly at all yet. But then again, you don't have to own a graphing calculator yet. I'm giving you the first week to get there. But where does it cross the x-axis for this guy? It crosses at the origin. It's going to go straight through that location. Where does it cross the x-axis for this guy? At -2. it's going to bounce at that location. This guy, it's going to twist its way through right there at the 4. Now, this is degree 1, 2, 3, 4, 5, 6. This is degree 6. So here we go, degree 6. That means it's going to go up on both sides. Up on both sides. So a list of facts here. And behavior. I drew a blank there. And behavior. When it's an odd degree function, it will go down on the left, up on the right. If you put a negative symbol in front of that, it will reverse that pattern. So if you had a negative odd degree thing, negative odd degree would go up on this side, down on that. So when it comes to even degree, when you have an even degree polynomial, I'm going to scroll down a tiny bit, that means it will go up on the right, up on the left. But if you put a negative in front of that, can you guess what's going to happen? I would reverse that pattern. I surely would, and it would go down on both sides. So let's talk about that with our next couple examples. So here we go. We got to draw a 6th degree polynomial for this example. Now, it means it's going to go up over here. It's going to go up over here. It is. But I gave myself a little bit of room because I see something that I have to do. My number 4 location, where x equals 4, it's going to twist. What does that mean? It's going to resemble a third power, or a cubic graph. Remember, our parent function for third power is a twisting function. So it's going to twist through that location. Now, my next location on the map here is right here at the origin. When I cross through there, I'm going to go straight through. There's no shenanigans. There's no twisting. It goes straight through that location. On the outskirts here at -2. At -2, I'm going to have to bounce. Doink. And it goes upward forever. So here we go. I'm going to get this little arrow out of the way so you don't see 2 of them. There. Take that in for a second. When the graph touches the x-axis, let me get a different color. When the graph touches the x-axis, but it doesn't break through it, it just bounces off of there. That's what happens when you have a second power in your polynomial. I'm going to get orange here. Let's see how orange sets up. Come on. When it's a third power, that's this guy right here. That means it's going to twist through that location. It's got some curvature to it. And then, of course, my first power, I didn't say anything about this at the beginning, but my first power dude for this one, it just goes straight through. There's no fancy stuff there. Just cuts right through the middle on that one. Now, it does not mean that second powers or bounces are always going to happen on this side of my picture and twists are going to happen here. They can occur wherever they occur. Let's compare that. But this is basically what you need for your notes. You need to know what first power, second power, and third power represent. This is the definition for end behavior. What's happening on this end of your graph, what's happening on this end of your graph is called end behavior. Let me go back, get a black pen, we'll do another one. So this time, let me call it g of x. I'm going to make this one say negative x to the second, and then I'm going to say x minus 1, and then x minus 3 squared. Now take a look at that. Is this going to be even or odd degree? Add up the powers, but guess what? They didn't put anything here. It doesn't mean it's not there. It's a 1. So now let me ask the question again. What do you think the degree of this is? I would say it's degree 5. This is a 5th degree polynomial. If it's degree 5, it normally has this kind of end behavior where it will go down on one side, up on the other. That's what end behavior means. But wait, don't act too quick. This guy has a negative in front. So we're going to reverse that pattern. There you go. That's what it's going to do when I sketch this graph. Now, on my last example, the same as this, I have this guy going through the origin. So if it goes through the origin, you do not have to list for me what the Y-intercept is, because I know what the Y-intercept is. When it doesn't go through the origin, then you have to worry about it. Okay, but here we go. I see it's going to hit the origin at 0. It is. It's going to bounce there too. It's going to go, what is it? Straight through, bounce, or twist through that location. Straight through, bounce, or twist. It's first power, so it's a single. It goes straight through. So it's going to go straight through. And then 1, 2, 3, it's going to bounce there too. There is not one single twist in this problem. But when I sketch these, I either start on the left or I start on the right. So where do you want me to start? Well, you can't answer. It's a video. So I'm going to say I'm going to start right at the origin. And I notice at the origin, this thing is going to bounce. So I'm going to draw this in pieces. I'm going to say, you know what? Here, it's going to bounce. But then that's the last train out of town. It's going to go doink. It's going to get rejected. It's going to come up. It's got to turn around somewhere, and I'm going to say there. That's where it turned around. Then I got to turn around somewhere, but I've got to come up here and bounce. Now, take a look at my picture. It is a rough sketch. You might not have made your picture go up this high. You may not have had your picture go down this low. But you can't tell me anything about those locations yet because you're not in calculus. When you're in calculus, you'll learn how to calculate how high or how low these things go to be perfectly precise. All I want you to know is the general form of how these behave. You'll notice, to draw that picture, I ended up going up on the left side. I ended up going down on the right side. It's degree 5. It was negative. I went through all the things. I have my bounce here, bounce, bounce. I have my bounce here, totally. It went straight through there, chaw. That is another example of a problem where you have a 5th degree thing. Now, take a look at my key, because I already showed you we have the assignments. Okay, here's the key. So if you want to pause it, take a picture of it, boom, there's the first 7 pictures. You'll notice on this first problem here, I labeled my Y-intercept because it doesn't cross at the origin. If it doesn't cross at the origin, tell me what the Y-intercept is. Now, here's another thing. This Y-intercept on this one turned out to be at 10. I just put a dash there and said, that's 10. I did not make 10 dashes. Here, I just called that 6. It crossed at 6. But you'll see, like, down here, this one crosses at negative 12. Did I make 12 dashes on the y-axis? No. Just mark it and label it for me. Tell me what it would be. But since we're here, let's look at this here. Here's this another set of answers. Pause it. Take a picture of it. Ignore this one that I messed up. But I did it right there. See, look. Oh, I did it right there. Okay, I'm going to get all that mess off my key. That looks horrible. Anyway, then, here we go. 15 to 20. There's the last ones. So, you know, if it crosses at the origin, I didn't list a Y-intercept because there isn't any real story to tell there. There's nothing really fancy. But if it did go through the Y somewhere else, I labeled it. And remember, all I'm doing to find a Y-intercept is I'm plugging in what if x was equal to 0. If x was equal to 0, what would happen? Okay. Now, I'm going to bypass my other examples here, but this is also good information. Maybe take a picture of that. And let's talk about the difference between factored form and pre-factored form. So I made up a couple examples, and I'm going to call the first one y equals, what the heck? And it says this, x cubed plus x squared minus 6x. So this is back in Algebra 1, back in the summer packet, all this stuff. I had you factor things because this is a skill we use a lot in Algebra 2. So I look at this and I say, okay, how do I factor it? Well, it looks like I have a greatest common factor. So I would take out the x. Then I would say after that, let's see, I would have x squared plus x minus 6. Then I look at that trinomial that's left over and I say, dang, I bet that trinomial factors. So I'm going to break it up if I can. X times x will give me x squared. To get a negative 6 out of this, I'd need positive and negative. And it looks like 2 and 3 is going to do the trick, but I have to get these in the right spot. Now, here we go. This right here is called pre-factored, because I didn't factor it yet. Pre-factored form. This is factored form. I already showed you that if I drew in the ones and I add them all up, 1 plus 1 plus 1 equals 3, this thing would be degree 3. If something is already factored, that's how we find its degree. But if it's in pre-factored form, please do not mess this up. That does not mean add up all the powers there. If something's in pre-factored form, the highest power is the degree of the polynomial. Let that sink in for a second. So if it's in pre-factored form, you look at the highest power and you go, oh, it's third power, third degree. If it's factored up, then you add these guys. It's the same, it's 3. That's the difference between factored form and pre-factored form. But you got to factor it anyway to sketch its graph. So here we go. Let's take a look at it. Now, the x-intercept is at the origin. The x-intercept is at -3. The x-intercept is at 2. I am not going to write out the y-intercept because it crosses at the origin. It's degree 3, and it's positive. The original problem's positive, so it's going to go down on this side. It's going to go up on this side. It's going to go straight through that kind of wobbled, but straight through at every single location. Nice looking graph, 100% credit. Loving it. Let's move on. Here's another one that is pre-factored form. So we're going to try this guy. X to the 4th minus 2x cubed minus, 15. Oh, I almost grabbed the wrong problem. 15x squared. Now, I could factor this. Now, I'm going to take out the GCF. They all have an x squared at least, so I'm going to take out x squared. That will leave me with x squared minus 2x minus 15, which is a trinomial. I will then bustify this thing, x and x, plus and minus, because it ends with a negative 15 here. Then I say, ooh, this must be a 3 and this must be a 5, and I got this thing factored up, and that means I have a bounce. I have a double right here. So I have a bounce at the origin. It goes straight through at negative 3. It goes straight through at positive 5, because these are both first powers. If I add up all those powers, I would get 4. I would, because this thing is degree 4. If I look at it in prefactored form, it says 4. If I look at it in this form, in factored form, add the powers up, I get 4. So this thing's even, and it's positive. So if something's even, there's no negative out in front of it. It's going to go up on the right, up on the left. That's what degree 4 would look like. I'm going to bounce right here. I'm going straight through at negative 3. I am going 1, 2, 3, 4, 5, straight through there. So what the heck, going straight through? I know it's going to go up when it goes through here. It's going to turn around somewhere. I don't know exactly where it's going to turn around unless I take calculus, but I'm just getting a rough sketch. Remember, sketch. I'm going to go up here. I'm going to bounce, doink. Then I got to turn around somewhere. Maybe it turns around there. Maybe it turns around somewhere else. I don't care. But I do know this. It's going to come through and go straight through and go up. Bam. That's a nice looking polynomial. That's a nice looking poly. Let's take a look at another one, because you're going to have some, like I showed you the worksheet at the beginning of this, some will have, let's see, 4x third. Some will be factored for you, some will not. 5x4 minus x to the 5th. Okay, now, I just want to make this point because I think you guys are going to get this anyway, but my last example, do you notice how I forgot to write equals y or equals f of x or equals something? I should have. But here's why I'm saying this. Look at my worksheet. I'm going to scroll to the top. Look at my worksheet. I wrote this out because I'm trying to get ready for the school year here, and I realized after I wrote this whole thing out, I forgot to put y equals or f of x equals for any of these. Mea culpa. That's, I think, Italian or Latin for I messed up. Anyway, I'm not going to go recopy it just to stick y's in front of everything. But, hey, I'm sloppy sometimes because I'm a human and I make mistakes. So let's pretend this said y equals. So let's go back into Algebra 1. Hey, Algebra 1 kids, when you have any kind of powers like this, what did they tell you to do? The first thing they told you to do was you should always write it in descending order. If you don't, you will be sorry. And you go, why? And they say, can't tell you now, but one day you're going to be in an Algebra 2 class and you're going to find out why. Here it is. Put it in the correct order. Then the other thing was factor out the GCF. Why? Well, because if you don't factor out the GCF, you're going to miss one of these magical things that happens when you graph it. I'm taking out x third, but here's the last thing they told us in Algebra 1. If the highest powered term, highest power, is negative, you take the negative out with the GCF. Now, I don't know if you remember that, but that is always true. So now let's build it backwards. X squared minus 5x minus 4. Did I do that right? Let's see. Nope, I'd need a plus there. Oh, crap. I forgot to write this in at the beginning. Hang on. Guys, if I was in the classroom, I'd be able to do this. He's here. Okay. I forgot that's supposed to be a negative. So when I pull out the negative, this would have to be a positive here now. Okay, sorry. I wrote a sign error down when I wrote down the original. But here we go. Let's break it up. Let's factor it. We're going to go x and x. Last sign's positive. The only way I can get a positive 4 is if these are both negative or these are both positive. And that's why I knew I had this sign error in there. Boom. Now it factors perfectly. Sorry about that. So what did I do? I broke it down. I said, hey, let's factor this thing up. I took out the negative high-powered GCF. I was left with a trinomial that factored into these two components. There's a 1 here. There's a 1 here. 3 plus 1 is 5. This thing is degree 5 if I add up their powers here. Or if I look at the original problem, in the original, the highest power tells you what the degree is. Let's sketch this graph. It is a negative degree 5 polynomial. Normally, a degree 5 polynomial will go down on the left, up on the right. But since I've got a negative degree 5 polynomial, when I sketch this graph, it's going to go up on this side, down on that side. Let's draw it. And what, come up, there we go. I'm going to hit the origin. I'm going to twist there. I'm going through at 1. I'm going through at 4. So here we go. I'm going straight through at 4, but it's going down. I am going to twist through the origin, but it's going up. So I'm going to draw this in 2 pieces. Sometimes drawing a twist in 2 pieces is easier, but then I got to turn around and come up through that one. Oh my gosh, connect the dots. I was just trying to connect it. That right there is a straight through. Look, straight through. It's a little wobbly. I just want to make sure you know. First power, straight through. Also, straight through. This is the only guy that twisted because he's third power. All right, so I've got one last example, but you might ignore me and go, you know what, I got it now. I'm going to just try and do these problems. But it's based on this one. Let me go up to the top again. Once again, you could have paused this at any time, taken a picture of the problems. But here we go. It's based on number 19. I wanted to do one that's similar to this. But I also haven't explained what happens when this kind of jazz happens to you, or this kind of jazz. Well, let's talk about that so we have it down correctly. All right, let me get those marks off there. So here's my last example. I'm just going to go all the way down to the bottom of this thing so I'm organized. In case I ever have to refer to this for you, I don't know. Here we go. My last example. Once again, on the worksheet, I should have said y equals, or f of x equals, or g of x equals, or something like that, but I did not. So here's this guy. My last example, and then I have covered all bases for you. Is this factored form or pre-factored form? This is pre-factored form. I want to know the degree of pre-factored form. So this would be degree 4. Degree 4. Degree 4 is even, but there's a negative in front of the highest power. So I don't want to draw this graph going up, up. I'm going to draw it with it ending, end behavior, down, down. So here we go. Oh, wait a minute. I need to factor out this GCF. So I will. I'm going to take out the x third. They both have an x third in common, but they also have a 2 in common. And since this guy's negative, the rule is it comes with the GCF. So I take negative 2 x third out of this thing. I am then left with not a trinomial, but a binomial. Let's work it backwards. This would have to be an x to make that make sense. This would have to be what? A minus 3, okay? Let's see what we get now. I am going to say it is going to twist at the origin. I am going to say that it is going to cross at positive 3 on the x-axis. I have this type of look. So here we go. Ready? Here's the twist. Here's the straight through. Remember, 3 plus 1 is degree 4. It's got to go down. So it's going straight down here, but it's got to turn around somewhere. It's going to twist its way through the origin. Beautiful graph. Now, let's kill 2 birds with 1 stone. What if this problem, just doing a total slight change to it, what if this problem, I'm going to call it h of x, what if this problem looked like this? Super subtle change. I only made one tiny little change. How would that be different? Well, I can't take out a 2 now. I can't. But I could still take out a negative, and I could still take out an x third. That would give me 2x. What would the sign have to be here? Minus 3. Did I do that right? Take a look. Yeah, I did that part right. Would it still twist through the middle? Yeah. Would it still be a 4th power problem? Yeah. Would it still go down, down? Yeah. Here's the only difference. How do I figure out where it crosses the x-axis now? Well, I know it crosses at 3/2. This thing crosses at 3/2. Or you could call it 1.5 or 1.5, whatever. That's where it crosses. But how do I know that? Well, when you're finding out where an x-intercept is, all you're doing in your head is setting it equal to 0. That's all you're doing. So if I add 3 to the other side and divide by 2, bam, there it is. So the only difference between my last example here, g of x, and my new example, h of x, is this. Come on. It would have still done this. It would have still done this, but it would have gone through at 1.5. Boom. That would have been where it crosses the x-axis. It would have still been a straight through. Okay. Sketching some polynomials. Good, big fun. Good, big fun for us. All right, guys. That's it. Remember, you could pause stuff if you need to revisit a concept or take notes or write down something that'll help you. I'm hoping you're finding these videos easy to understand and follow. If not, let me know when we get together on the Zoom for classes. Okay, guys, have a great one. Bye-bye.